At Dynamic Alpha Automotive Technology, we are excited to unveil the Dynamic Flow engine, a groundbreaking four-stroke engine that redefines efficiency and performance. This innovative design features a unique valve configuration that enables early intake valve closing, EIVC, facilitating the simulation of the Atkinson cycle in both Otto and diesel engines. The Atkinson cycle, recognized as a proven method to improve combustion engine thermal efficiency by utilizing a lower compression ratio than expansion ratio, has historically faced challenges in widespread adoption due to compromises in power output and marginal efficiency improvements over conventional Otto or diesel cycles. The Dynamic Flow engine addresses these limitations with its advanced EIVC Atkinson cycle implementation. This innovation boosts thermal efficiency beyond 48%, achieving an impressive range of 60% to 75%. The result is a transformative improvement in fuel economy, enabling sedans equipped with a dynamic flow engine to achieve up to 90 miles per gallon and full-size gasoline trucks to reach up to 66 miles per gallon. Problems with current four-stroke and two-stroke engines. Conventional four-stroke Otto and diesel engines can only simulate the Atkinson cycle using a technique known as late intake valve closing. This method involves adjusting the intake valve timing so that the valve remains open beyond the intake stroke, past the crankshaft's bottom dead center, and into the compression stroke. As a result, some of the intake air is expelled from the combustion chamber before the intake valve closes, reducing the compression ratio relative to the expansion ratio. However, this late intake valve closing technique introduces significant pumping losses. The engine must expend energy to pump air into the combustion chamber during the intake stroke, and a similar amount of energy is required to expel a portion of this air during the compression stroke, all to achieve a lower compression ratio. These pumping losses become more pronounced as the Atkinson cycle effect is increased, limiting the potential gains in operational efficiency that the Atkinson cycle could offer in current four-stroke engines. Moreover, attempts to enhance performance using turbochargers and superchargers in engines with the Atkinson cycle have proven inefficient and ineffective. This leads to lower power output and reduced acceleration compared to traditional Otto and diesel engines. Currently, only one automaker employs this technique. In the case of two-stroke engines, simulating the Atkinson cycle is not feasible due to their operational characteristics. Benefits of the Dynamic Flow engine's Atkinson cycle. The Dynamic Flow engine's ability to implement early intake valve closing to simulate the Atkinson cycle in Otto or diesel engines provides significant advantages, such as improved thermal efficiency without the pumping losses typically associated with late intake valve closing, and enhanced power output through the use of turbochargers and superchargers. In conventional four-stroke engines, the valve configuration makes early intake valve closing unfeasible, as it could cause the intake valve to collide with the piston head at top dead center during the end of the exhaust stroke. Attempts to modify the piston head to accommodate early intake valve closing would disrupt the combustion chamber's compression characteristics, resulting in reduced engine performance. The Dynamic Flow engine overcomes this limitation with its innovative design. The upper intake valves are positioned outside the combustion chamber, so their timing, whether advanced or retarded, is unaffected by the piston head's position at top dead center. This unique feature allows for a full range of valve timing adjustments, optimizing both efficiency and power output.